All right, wonderful. Well, thank you very much for being here. So I jotted out a few things just to frame this. So MapR, obviously one of the key, perhaps the key distribution of Hadoop. And as such a cornerstone of the big data ecosystem. The company started in 2009, based in San Jose, California. You guys have raised 174 million in VC money. Most recently, it was 110 million round from Google Capital. And the last number I had was 350 employees. Does that sound about right?
It's more like 400 now.
It's more than 400. Okay, well, congratulations on all of this. So, anyway, that was just to give people a sense, or I guess more detail about at a high level what you guys are, where you are in the arc. So let's get started. So as one of the previous speakers mentioned, this is absolutely an event about data and big data, but it's also an event about entrepreneurial journeys and personal journeys sometimes. I'd love to start with that, with what your personal journey is through Spinnaker and Google, and what was the founding story of MapR?
Yeah, I mean, so I was at Google and working on search. So I was one of the guys who worked on the core search engine. And it was incredible for me to see how much this technology was processing data like crazy. I mean, just incredible. I mean, even having worked on it for 3 years, I was still impressed by it. And then this small company called Facebook started with like 100 people, and everybody in Google started moving there. And I said, man, what is this? And then there was another company called MySpace and Orkut and Ning, and everything. Everybody was social, and everybody was doing this. LinkedIn was kind of the whatever. And so I said, well, let's look at what are they doing. And there was this thing called Hadoop everybody was using. And I had a lot of friends who said, man, if you want to do something, why are you looking at search and this thing? And when do you go and do something with Hadoop? So I said, Hadoop, I can't even spell this thing. And then I looked more and had even more strange names like Hive. And Hive actually didn't exist. It was Pig. And I said, what is Pig? And then it has something else. And I was just, all right, I give up. And so then we took a look. And, it became more and more popular. It was getting extremely popular in the Bay Area. Everybody was using it. So I said, well, why not bring my skill from file systems and storage? Big data is really two things, big storage and big processing, and different kinds of processing, and that processing stuff changes a lot. But like as Stefan said, the big data storage, well, it's going to last. So let's try to bring that and build that as a Hadoop distribution. That let's worry about the storage problem, let everybody else worry about the compute problem, and try to build a Hadoop distribution like that. And so that's what we did.
Right. And still on the entrepreneurial journey part. So what were how do you start? How do you hire employees?
Yeah, right? So it's a bit challenge, right? I mean, you have to hire friends first, because think about this. I had a bunch of friends and I was trying to hire, and this actually happened to me. I had $20 million in my pocket, but no building, right? And I'm trying to hire people, and they come and they look at this little room with no chairs. And we had unscrewed a door and used it as a desk, because we didn't have a desk. And of course, some guys who came in were very excited that I'm getting into a company really early. And the other guy said, you don't have a coffee machine, I'm not working here. They would just walk out. So it was a challenge trying to hire in the beginning. I think that's the number one problem, and you have to try to hire people who are not like you. I mean, basically that's the first advice. Because you tend to be attracted to people who are like you, and in the beginning you really want a big variety of people and not from the same DNA. It's very important. So that was a big challenge.
Was it a purely technical team initially, presumably, right?
Yeah, it's purely technical.
When did you hire your first salesperson? Did you already have a customer? Did the engineer start selling and then you brought on a salesperson?
Yeah, so the sales was I did a lot of the. Before we started MapR, I spoke to about 40 or 50 people who are using Hadoop, 50 companies, asking them, is this something, if I build this, would you buy? How much would you pay for it? And they would lie to you, right? It's always the same thing, right? When you go and buy something, you say, I'm going to buy 200 of this, and you really buy one, but because you want the lower price, right? And it's the same story. So many of them told me, but what you hear is the features that they want and what is their problems and what they think is a big problem. And then you try to hire the engineering team based on what you're going to build. The problem is that you'll be wrong, right? Whatever you guess, you're wrong, because for us, it took us 2 years to build a product. But in the 2 years, you got your head buried. And when you lift your head out of the sand, the world has changed. And so won't be exactly right on what you come out with. And so you have to build a product that's flexible to be molded into as the world turns. Because the way this venture money flows is that you get the first bunch of money for building the product and not again. After that, you get the money for selling it. So if you miss very badly in the first one, your company is going to be shut down. Right? So because the market might have changed and you can't control the market. All you can control is your product. So that's the main challenge there.
Great. So fast forward to today, and I guess let's go into what MapR is today, and so specifically maybe start with MapR FS and start going into the details, what the product does, and then we'll go into
so here's what MapR, I think the best example about MapR, let me give you two examples. One is a more down-to-earth example, and the other is a very touching example close to my heart, right? So one is we are now, from a file system perspective, we are powering one of the largest email providers in the world. Okay, when I say largest email providers, everybody of you probably is on it. 1.5 billion email accounts. They have about 1.5 or 2 trillion files. They create about 20 billion files a day, delete 18 billion files a day, which is a different set of files. They have about 200,000 email accounts created daily. Many of them are spam accounts, and about 190,000 of those are deleted every day because they're spam. And so that's the size, right? Now think about email, right? Your cell phones are checking email every 3 seconds. And let's say half the 1.5 billion users are active. So you have 750 million users checking every 3 seconds. So it's 250 million requests per second. On a database, that's 20 billion new files a day over 3 weeks. So 3 weeks is very hot. So 420 billion files, right? 20 times 21. That's the kind of database this is running on, right? So that's the file system we built. They are seeing 6 nines uptime, which is about 10 times harder than a 5 nines uptime. Okay. So, and it's multi-temperature. We can move the data across from, so the first 3 weeks is on flash storage, completely flash. You can't serve this from disk. Then after 3 weeks, as the data gets very you want to move to cheaper stuff. Flash is still very expensive. So it moves to very dense hard disk based thing, automatically policy based under the covers. So we're the only ones who do that today. And that's what we started off from Google trying to build.
How does that differ from the core HDFS? Why would one use MapR?
So look at email. Email is small files. So okay, we have one very simple example. HDFS, a single cluster can do about 100 million files, right? So just to hold 1 day's worth of data, you need 200 clusters, right? 20 billion files is just 1 day. It's full. 200 clusters are full. You want to run 200 name nodes? Go for it, right? Another issue is small files. I mean, email is 600, 700 bytes. It actually is bimodal, so 600, 700 bytes, or these attachments are 2 megabytes or something like that. So about 95% is small, and then, so it's in two peaks. HDFS, and then the response time, if I'm, that load, 250 million queries per second over that many files, you got to respond the budget is about 20 milliseconds. Because otherwise you think your email is not working, because by the time it comes across the cloud somewhere, you need about 200 milliseconds is the typical human response time, 250 milliseconds. So our budget is 20 milliseconds. So to make that, I don't think HDFS can do any of this, right?
Great. Right. All right. So that's one core part, MapR FS. Let's talk about MapR DB.
All right. So that's the other example. So MapR DB, we built a database. So we started off doing HBase. So I did Bigtable in Google. And actually, somebody put a slide on NoSQL. So I was saying, well, that's really not the history. But so the history really was that everybody was using MySQL, and you put memcached. Remember that thing? And then they married it together, and you lost all the consistency. And they said, all right, that's okay. We'll call it MySQL, MemSQL or whatever. No, sorry, that's a different company. Shouldn't say that. So memcached with NoSQL became Bigtable, and then that became all the other kind of the precursor for all the NoSQLs. But we kind of came back to the bigger problem, that is, can we make this a system of record? Can we put clinical records? Can we put real money inside this? And that was a big challenge because everybody was using Oracle. Oracle still is making $60 billion a year. And how do you build on this new technology something that can be at that level of reliability? So we built MapRDB to do that. And the example I would use there is it's now used in India. In India, let me first describe the problem in India, and then it'll be an interesting story here, which is Indian citizens, about 70% don't have birth certificates, right? So I don't have a birth certificate, for example. It's because I was born somewhere and nobody bothered. And so officially I don't exist, right? I mean, there's no way to prove who I am. So the way it was traditionally used is in either my 10th grade certificate or 12th grade certificate is how you kind of figure out approximately when he was born and whatever. And but there's a lot of people, therefore, so now the Indian government puts out a lot of money, about $100 billion a year in welfare for the people, in terms of cash and food and fuel and free education and all that. But it's stolen all the way, and when it comes down, trickles down all the way. And why it's stolen? Because the guy on the bottom is going to just steal it and say, yeah, I distributed it. And if you challenge him, who did you give it to? He produces a list of names. And there's no way to verify these people even exist, right? Because they don't have birth certificates. They don't have any identity. And so these people are off the social grid. So about 6 years ago, 30 or 40 Silicon Valley CTOs and CEOs kind of pro bono moved to India and built a system on Hadoop to basically with biometric identification to identify every person in India, right? And so the population is about 1.3 billion. So now they are bringing on at the rate of 1.5 million people a day. The database is currently about 900 million people. A person's fingerprints, all 10 fingerprints and 2 irises, are about 5 megabytes in size. Right? At the rate of 1.5 million a day, they're going to go for another 2.5 years before everybody's on. Now, this is running on MapRDB in 4 data centers worldwide, across India. System of record. And it's used for everything. It's used for airport entry, for opening a bank account, opening admission to hospitals, schools, getting pharmacy. This year it was used for filing tax returns and all that. We gave it for free, by the way, right? Because we thought it was very important. But here's a very nice example of how it's really impacted people. So the Indian government has put out battery-operated ATMs on the 2G network, biometric ATMs across the country. Anybody can go in there. If they have this ID is called an Aadhaar ID, go and put in your fingerprint, you can open a bank account right there at the ATM. Because these people are uneducated, there's no point of having a statement and all, they can't read it. And now they can do cash transactions. So if you imagine a widow who was getting her husband, she's 80 years old, lives in a village, her husband died maybe 20, 25 years ago, and she collects the pension. Right? Well, what she had to do before the system came along was she has to prove she's alive and prove that she was married to this guy and he's dead. But all three have to be proven. And so how do you do that? Notaries, right? You get notarized letters saying, yeah, I know that she is really this person, by witnesses and all that, and do that every month. Right? And you bribe everybody, then you walk to a village another 20 kilometers away to get the money. Now you go there, that guy is a crook, right? What he's going to do is, she doesn't know that there's something called inflation and that the money she is getting has now tripled in the last 20 years. She still gets the same money she got then, 20 years ago. right? And the other guy, he pockets the other 2/3, right? Now that system is completely changed. Today, what happens is she can use any cell phone, right? Take the camera, get a retina scan or a fingerprint. The software is integrated on a cell phone. She can open a bank account anywhere. And that proves she's alive, who she is, everything. And the money is transferred directly, no middlemen, into her account by the government for pension payments directly. No middlemen. It's immediate, she doesn't have to go anywhere, and she gets the whole thing. Right? This is how people are getting transformed in India, in everything. Now, now 2 months ago I was in Paris, and I kind of presented this somewhere, and they said, well, this will never happen in the Western world, because we're going to track everybody, whatever. And now suddenly, after the Paris attack, I heard completely the opposite, which is, we're going to track everybody now. So, so it's a kind of very nice use case.
Wonderful. Very interesting story. Tell us about streams. So you guys just released.
Yeah, so streams we did for another very interesting use case. So how many guys have heard of self-driving cars, right? Everybody has seen one or at least seen one. How much data do you think a self-driving car produces? Anybody guess? Anyone? I'm going to do the Stefan game. Anyone? So it's a single self-driving car produces 1 terabyte per hour. So if I have 5,000 cars, that's 5 petabytes an hour. Okay. Now, how long does this data have to be captured? So where are you going to put it? You can't even get it out of the car somewhere else. So all new cars are like 10 gigabit, dual 10 gigabit networking, 100 gigabit networking inside the car. And remember where in the trunk you had the 6 CD changer previously? Now they have 6 node Hadoop clusters there. And think about what's going on. So they're doing processing at the edge, right? But this data is so important. Think about 2 self-driving cars or self-driving school bus with 5 children going off a cliff, or they have an accident or something, right? Whose fault is it? Is it the camera that in the front that, the 4K cameras that every car has? Every car has 4 4K cameras. Is that the problem? Is it the LiDAR the problem? Is it the suspension system? Is it the braking system? It's the ignition system, the engine, the fuel system. What was the problem that caused the accident? Do you know how many components are involved and how many manufacturers are involved? Imagine the lawsuits, right? So the problem there is they need to capture this data. This is seriously big data, all right? And it has to be streamed, it has to be captured, it has to be analyzed. And there is literally, probably the only guys in the world we can do that today at that rates, MapR, right? So it's taking Hadoop big data way beyond Hadoop, right? This is talk about super real time, about 200 million data points a second. We're seeing this in many, many places, in planes, we are talking to some of the defense forces where they're putting this into submarines or into trucks that go out into the desert for 3 days or 4 days and then come back, and they have to process this and in drones and everywhere, right? So it's a very big challenge, and I think the real next scale in Stefan's graph is you need thousands of clusters that do edge processing everywhere for this kind of data, inside drones, inside those hover things, and inside everywhere. What are those things called? I forgot the name. Just a mind blank. Those, the Amazon wants to deliver things with. Drones still? Okay.
UAVs.
So those things, yeah. So I think that's what streams were built to do, is connect hundreds of thousands of clusters in reliable way across the world, deliver data at milliseconds, reliably, guaranteed delivery, and hold this data for 2-3 years. Because an insurance guy might come in and want to take a look at it to see what happened, right? What caused the problem. So
and Stream is an alternative to Kafka, which is an open source paradigm.
Yeah,
how do you guys think? So Hadoop fundamentally is an open source product. How do you think about that tension between?
Yeah, so that's very good question. This is a very good question. I get asked this a lot. So we think of ourselves as Ethernet, right? There is no MapR API at all. There isn't one, right? So you cannot program to a MapR API. Think of it as like Ethernet, right? You get a better switch, you unplug that one and plug this one in. You get on one later, a better switch, unplug that and put another one in, right? We just, if it's a well-defined specification, you can keep improving your technology without changing the interface. So that's the basic idea behind MapR. So we're completely standards based. So, and if you can find an API that's already there in the public domain so what's very important is no single vendor API is also very important to us. So that's lock-in. No single vendor API. Not just no MapR API. It's beyond that. It won't be your proprietary API either. So what's very important is that if there's an API we can hide or innovate under, we will do that. So Kafka is an example there. When there isn't an API, we will invent it and put it in open source, like we did with Apache Drill, like we did with Ojai or whatever it is, Ojai, Open Java, Open JSON interface. We introduced JSON to Hadoop in Spark and in MapReduce and in Hive and everywhere. So we put that in the open source. So wherever possible, if there is no API, we'll do it in the open source. And we don't, build something for the fun of it, right? It's back to basics when we build something is that talk to customers. Is there a need here? Don't just go and build technology because anybody can build technology. But if nobody's going to buy it, it's like you're going to run out of money pretty fast. So you have to build something that people want to do something with. Right?
And the Hadoop distribution world is fairly ruthlessly competitive. We had Mike Olson from Cloudera here a few months ago. And we talked about open source. Hortonworks seem to be very focused on the sort of open source part. How do you guys? What do you guys say to customers who want to build a big Hadoop implementation and think about those three companies? How do you guys differentiate?
So we differentiate on the storage platform. So these three things: the database, the file system, the streaming, which Hadoop cannot do, which open source cannot do. But there's a lot of, open source means many things, right? Is it free? Well, everybody knows I can give you a puppy for free, but you got to now pay for the vet, right? I mean, you know that, right? Is it no single vendor API? I think that's critical. You don't get lock-in. No single vendor API. It doesn't matter it's open source or not. No single. Ethernet is not open source. So what, right? I mean, it's a great API. Same thing, what's the third one, right? Can a lot of people participate in building this? That's the third part. Is there a community around it, right? That's part of the open source. So I think that's a bit disingenuous on Hortonworks and Cloudera's part to say that, because they would like to, so here's the dirty little truth about open source also, right? Open source vendors, right? I love open source as long as it's my open source and not his open source, right? So you have couch guys don't like Mongo doesn't like HBase doesn't like Cassandra and all of that stuff. And similarly in the open source world is with Hortonworks and Cloudera is that, they want a community as long as they can control that community. So you have this funky thing where, Impala is controlled by one company, Yarn is controlled by one company, or now Kudu or something. Just because it's open source doesn't mean they're giving up control, right? Spark is controlled by one company and so on. So that's the reality, right? So when you say I'm really saying open source and somehow I'm going to get more people to participate, well, maybe, right? But I can do the same with just talking to, and maybe sometimes with closed source you can deliver things faster and more robust compared to open source. So I don't know. I think the jury's out on that. It's not clear that open source equals good quality yet, right? I think one product, open source equals good quality, has been there, and that is absolutely true with Apache Web Server. Fantastic product, right? I think open source with Mesosphere, I think, has been another example of very good product. I would say it's a fantastic product. Also controlled by a company, though.
What about Drill?
I think Drill is getting there. Drill is there are two companies with Drill, and actually I think now there's three. Right, there's three companies doing Drill. But and by the way, the Drill optimizer is what's in Tez as well. So and in Spark SQL. So it's the same optimizer, and that's built by Drill guys. So Calcite. Right, so so there is good sharing of technology that happens. I think at the product level, I don't think it happens as altruistically as you'd like to imagine. right? But I think lower level it happens.
Great. So just one last question from me, and then we'll open it up to people. In high level, but I'm sort of fascinated by the topic and the answer. So where are we in the, I guess, evolution of Hadoop and big data as a mainstream product? I mean, have we crossed the chasm? Is that you mentioned some amazing stories, but are we there? Are we, or is that just the beginning?
I mean, if you ask, so that's different, what do I know, right? I mean, we have about 1,000 customers now, right, in 4 years. And I think we're the smallest Hadoop of everybody, right? I mean, whose Hadoop is bigger kind of thing. You used to have a cartoon, whose Hadoop is bigger. Stefan used to have that. So anyway, it is. So I think the way it's true is that every company now has a Hadoop budget item. Almost every company, and every company is saying that if I don't do big data, my competitors are going to overtake me. And it's very true. I think I'm going to borrow that line from you. There's data complexity is going like crazy, and if you do fixed schemas, you're basically you're going to be in trouble. So the only technology that's there, so I think that's the fundamental key, is that if you have a lot of data coming in, you cannot sit down with fixed schema. What's your alternative, right? Maybe it's Hadoop, maybe it's Flink. I love Flink as well. Maybe it's a lot of other things, but I think the compute framework is always going to evolve, and you have to be agile and nimble, I think. But I think the old schema, rigid schema is gone. I mean, if you're still waiting, thinking that's going to come back, it's not. It's over.
Great. All right.
Right, yeah. Any questions? Happy.
Question over there.
All right. So this is not a technical question. I'm sorry, very heartened to hear about the India story and using the Aadhaar identity. But I was wondering, how widely is it used? You talked about a phone and taking a picture. Are these kinds of phones commonly available to people?
Yeah, I think so. Even the oldest Nokia cell phone nowadays has a camera, right? And the software recognizing the iris stuff is running on the back end. Iris is stable so it's used very widely. Okay, it's used for all tax returns. There's 930 million people online right now. You cannot do anything in India without. In fact, India is now looking at getting rid of even visas because they know who you are. In fact, they don't even have to have a visa to go to. If I come from India to the United States government can directly check from your fingerprint who you are. We don't have to sit down and do any visas, passports. We know who you are, right? And it's still safe, right? I'm leaving my fingerprints all over this glass and everything. It's not like suddenly, I left my fingerprints. Right? It's all over the place here. So it's still safe, but it is. I think it's dramatically in India. It's dramatically impacted everybody. Everything like food in schools, in fuel like gas cylinders or kerosene or even clothing. Now there was massive floods in Chennai in India where last I think entire month they were flooded like they've never been in 100 years. And everything came back to normal because of from identity you could figure out. People lost their entire homes, and the only way they knew who they are is now where do you get to prove that you are who you are? How are you going to do it? Well, your fingerprint is still with you, right? I mean, they got their everything was gone. I mean, all your school certificates, college certificates, your bank statements, everything was gone. Right? So. And so over 50 million people affected, right? So it's being used there as well.
Thank you so much for sharing. I was particularly interested about the story you're telling, the project you did in India, and I was curious. I think a lot of us are really interested in having an impact. That's what's exciting about data science is it's directly impacts so many things. I'm curious what other organizations there are or opportunities there are to sort of volunteer data science services or other projects like that. It seems like this was sort of...
this is an extreme case, right? Because you needed support. So I have been approached by the governments, of a lot of governments in Africa, a lot of governments in Asia to do this, or even in South America. They have similar extreme corruption and extreme problems. But this happened because it started from the prime minister down. he put his foot down and saying this is going to happen. And then there was an election, the government changed, and the new guy said, absolutely, this is going to happen. So you need, for something like this to happen, it has to happen from the top. What's happening with your Obamacare here is happening from the top, right? It cannot happen unless there's that much political backing. So this kind of thing is an extreme case, right? And we just got lucky to be in the right place at the right time. So that I'll grant, right? You need some luck too. But I think, sorry, please go ahead.
You were at Google before, and a lot of this industry was created by Google releasing some white papers on how they do things and people catching up with it. I'm very curious, now that you're on the outside, do you think that Google still is one step ahead of everybody internally and they'll release some more things that you'll find out about, or do you think that the industry is so active now that you caught up?
So I left Google about 7 years ago. So all my answers are based on then. So they were very ahead of everybody. They were ahead of everybody in 2000 itself. Like in the sense that they were the 20th search engine on the planet, right? I mean, everybody thought search was a wasted problem. And then suddenly Google appeared and wow, everything worked. I think Google is very ahead in some technology areas. Google now is almost scary how it knows everything is going on with me. But you know, I think there are a lot of other companies also very smart, right? I mean, Facebook is doing fantastic things. Yahoo is doing fantastic things. I mean, brains is not, you know, somebody's private reserve, right? I mean, anybody can do it. I think in a way, good ideas are for free. I think anybody can do it anywhere. So technology-wise, they are more advanced, but there's only one Google and one Facebook, right? And everybody else is not like that. So don't try to do that. I mean, as a startup, that's very extreme.
Thank you for presenting. It's really great to hear you talk, even your personal experience. I've used MapR. I love it. I was using Hadoop before that, but moving to MapR was a big upgrade for us, and including actually scaling down. Like, it was just easier to work with the data because you provide the native Unix interface to things, which made things a lot easier. And so my question is, I saw that as one of the biggest effects to my I own a software company, for context. So I have a lot of engineers working with things, and being able to work with the MapR file system was just so much easier than working with the Hadoop file system. But MapR is very much considered this package of Hadoop, like your own special installation of Hadoop. And I know we would like to see the MapR file system exist outside of Hadoop. Like, we would like to see much more distributed storage and other access points outside of this context of Hadoop. And I was wondering if you had any thoughts on that kind of thing.
So actually, we've actually gone down that path, right? So the one example I gave you with the email was an extreme example of there's no Hadoop. It's purely storage, right? They just use it through NFS and through POSIX. We have a POSIX client as well, just a native. But I think the reality is you're going to do something with it. Even the email guys are eventually going to run Hadoop to analyze the email and find new threats, you know, new phishing, new porn, and new spam, right?
People implementing other things like Hadoop on top of MapR?
Yeah, I mean, I see people implementing their own frameworks. I don't know if it's open source or not, but absolutely, I absolutely see other frameworks there. In very big scale, by the way. So, I mean, these are private companies doing it. Absolutely. I mean, it's basically big storage and big processing, so you know. Yeah, please.
All right, let's keep it this to 2 minutes. Yes.
Stefan mentioned that Mesosphere, or in his presentation, he had it as the Hadoop killer. What are your thoughts on Mesosphere?
I think he meant Yarn. Yeah, so as a scheduler, so you need three things. You need storage, processing, and a way to manage resources. And I think I think Yarn and we built a project, so I'm not kind of so much on the fence that it's the killer. So we built something to bridge Yarn and Mesos called Myriad. So Yarn can run as a subcluster inside a Mesos cluster, mainly because Yarn actually does MapReduce very well. Mesos doesn't do that well. But I think everything else Mesos does very well.
All right, wonderful. Srivas, thank you so much for being here with us today.
Thank you.